The Origins of the People of India, Part 3. What ancient DNA reveals about the origins of the people of India? The contents of this video are based on a website that I created on this topic. The website is available at https://sites.google.com/view/ourorigins/home. This presentation is provided for educational and informational purposes only. The data is gathered from various external sources. Their inclusion does not constitute an endorsement of the original authors, their viewpoints, or their methodologies. The content should not be construed as a criticism, negative evaluation, or disparagement of any individual, their opinions, their beliefs, any organization, any government, or its departments. Every effort has been made to ensure the accuracy of the data presented. Any inadvertent errors or omissions are unintentional and will be corrected upon receipt of verified data. The audio has been generated using Google TTS. Some names and scientific terms might be mispronounced. Your understanding is appreciated. Geopolitical designations such as Iraq, Syria, China, Americas are recent and did not exist several millennia ago. They are used in this presentation to provide geographical context. BCE stands for Before Common Era. BP stands for Before Present. For example, 8,000 BCE equals 10,000 years BP because we are in the 21st century. 8,000 plus 2,000 equals 10,000. The dates are approximate and could vary by decades or even hundreds of years. In the previous video, we discussed how ancient DNA is analyzed to understand the origins of people outside Africa. Based on a study of the Y chromosome and mtDNA haplogroups, it is accepted that a migration of Homo sapiens out of Africa, about 60,000 years ago, populated all the other continents of the world. Today, Homo sapiens is the only surviving species of the genus Homo. Homo erectus, Neanderthals, and Denisovans were extinct. There are two theories about the origins of the people of India. One theory suggests that some of the ancestry of people in India comes from populations that lived outside the Indian subcontinent. This migration into India influenced the culture, religion, languages, and social practices of the people of India. This is sometimes called the Aryan theory. A competing theory argues that the people of India have no ancestry from outside the subcontinent, and that populations from India migrated outward, spreading their genes and cultural influence to other regions. This is sometimes called the Out of India theory. In the rest of this presentation, the terms Aryan and Dravidian will not be used, as they tend to cloud the debate and detract from the scientific discussion. In this video, we examine two landmark papers published in 2019 that have brought greater clarity to the debate. One paper, published in Science, was based on a study of the DNA of 523 fossils ranging over a period of 8,000 years, mostly from Central Asia and northernmost South Asia. The other paper, published in Cell, was based on the study of a single skeleton found in Rocky Gari in the state of Haryana. Both papers arrived at similar conclusions. We will also look at the role of agriculture in the formation of communities and the use of linguistics to determine the origins of the people of India. By 15,000 BCE, 17,000 years ago, all the continents of the world had been populated. The people were hunter-gatherers who lived a nomadic lifestyle in search of food. About 9,700 BCE, 11,700 years ago, the Earth started to get warmer and average temperatures rose by about 3 degrees Celsius to about 11 to 12 degrees Celsius. This was the beginning of the Holocene era. By comparison, the average temperature now is about 14.5 to 15 degrees Celsius. The warmer weather and stable rainfall patterns of this era allowed wheat and barley to grow in the wild, especially in the Fertile Crescent. The Fertile Crescent comprises Iraq, Syria, Jordan, Lebanon, Palestine, and parts of Iran. The people in the Fertile Crescent harvested and consumed the food grains growing in the wild. Over a period of time, they started to cultivate wheat, emmer and einkorn, barley, lentils, etc. People in China cultivated millet and rice about 8000 BCE. There is evidence of barley, wheat, and date farming in Mehrgar in present-day Pakistan. It is believed that these crops originated in the Fertile Crescent and spread to Mehrgar by trade or migration. There is evidence of rice cultivation in Lahura Deva in Uttar Pradesh about 7000 BCE. Corn, squash, beans, and potatoes were cultivated in Central and South America about 4000 BCE. Livestock like cows, goat, sheep, and pigs were reared, and their skin was used as clothing. Irrigation systems were developed. Cultivation required people to stay near their farmland, resulting in the formation of communities and later the development of civilizations. One of these communities was Mehrgar. This figure shows the development of agriculture in various parts of the world. It is generally accepted that agriculture started in the Fertile Crescent. The Euphrates and Tigris rivers were fundamental to the rise of agriculture in the Fertile Crescent. There is evidence of agriculture in the Yangtze and Yellow River valleys of China around 8000 BCE, and in Mehrgar and later the Indus Valley Civilization in South Asia, starting from around 7000 BCE. Farming started relatively later in sub-Saharan Africa, the Andes region of South America, and eastern North America. This figure has been generated using Google's image generation tool. Why is it important to study Mehrgar? Mehrgar is one of the oldest communities of humans. It was continually occupied from about 7000 BCE to about 2500 BCE, about 4500 years, providing a wealth of archaeological and genetic evidence. After 2500 BCE, the people of Mehrgar moved east to a place called Nowshera, about 6 kilometers away. By comparison, the Sumerian civilization lasted from about 3500 BCE to 1900 BCE, about 1600 years. Archaeological evidence shows a continuity in agriculture, wheat, barley, and crafts between Mehrgar and the IVC. How was Mehrgar populated? Mehrgar had an indigenous population. We saw in the previous video that the Indian subcontinent was among the earliest to be populated by people migrating from Africa. In addition, there was interaction or movement of people and ideas into the region. Where did this movement come from? There are two possibilities. They could have migrated eastwards from Iran, or they could have migrated westward from India. This figure shows the location of the Zagros Mountains, Mehrgar in Pakistan, and Lahuru Deva in India. Were agriculture and cultural practices of the people of Mehrgar influenced by people migrating from the Zagros Mountains or from Lahuru Deva? This figure also shows the Hindu Kush Mountains in northern Afghanistan. We will see later in this video that people from the steppe region of Europe migrated into the region of the Indus Valley Civilization by crossing the Hindu Kush Mountains. This figure was generated using Google's image generation tool. There is evidence for agriculture in Gujarat around 3700 BCE and Malwa in central India around 2700 BCE. However, these dates are later than Mehrgar. There is evidence for rice cultivation in Lahura Deva in Uttar Pradesh, dated to 7000 BCE. The crops in Mehrgar were wheat and barley. There is no evidence of rice in Mehrgar. Evidence from agriculture suggests that the people who lived in India did not influence agriculture or populate the Mehrgar region by a westward migration. Excavations in Mehrgar show quadrangular houses made of narrow bricks, 60 centimeters long with finger marks for the mortar. Excavations at Gunj Dere and Ali Kosh in the foothills of the Zagros Mountains in Iran show similar houses. Circular fire pits, red paint on the outer walls, and multicellular granaries have been excavated at both Mehrgar and in Gunj Dere and Ali Kosh. The archaeological evidence supports an eastward migration of people and ideas from Iran, which influenced the people who were already living in Mehrgar. We will now discuss the paper titled The Formation of Human Populations in South and Central Asia by Narasimhan et al., which was published in Science in September 2019. This paper analyzed DNA from 523 fossils spanning the last 8,000 years from 3 regions, along with 19 previously sequenced data. The regions are Turan, Turkmenistan, Uzbekistan, and Kazakhstan, steppe regions of Europe, and Swat and Chitral districts of North Pakistan. Researchers co-analyzed the genetic data from ancient DNA with the genomic data from present-day individuals and reached certain conclusions. The chapter on Mehrgar at https://sites.google.com/view/our-origins discusses this in detail. The researchers reached these conclusions. People from the steppe region arrived in the Turan region by about 2100 BCE. They moved east into present-day Pakistan and northwest India to the region of the Indus Valley Civilization between 1900 BCE and 1500 BCE. By this time, the mature phase of the IVC had declined, and there was movement of people from the IVC to the Indo-Gangetic Plains and toward South India. The pastoralists from the steppe mixed with local populations, contributing to the spread of their genetic lineage. Steppe ancestry in South Asia is primarily from males and disproportionately high in Brahmins. The people of India derive their ancestry from 2 groups called Ancestral South Indians, ASI, and Ancestral North Indians, ANI. ASI derive their ancestry from ancient ancestral South Indians, AASI, who represent the people who migrated several millennia ago from Africa, and Iranian hunter-gatherers, and/or herders. The authors use Andaman hunter-gatherers, AHG, as a proxy for AASI. ANI have a mix of AASI, Iranian hunter-gatherers and herders, and pastoralists from the steppe region of Central Europe. This figure shows the results of the study by Narasimhan et al. The people of the IVC formed from a mixture of indigenous South Asians and a deeply related Iran ancestry hunter-gatherers. They formed the ASI. They had no steppe ancestry. The people from the steppe region migrated into the IVC region via the Hindu Kush Mountains and mixed with the people living in the IVC, forming the ANI. Indians today are a mixture of ASI and ANI. Who are the pastoralists from the steppe region whose genetic evidence is found in some communities in India? They are the Yamnaya, who were a nomadic pastoralist culture from the late Copper and early Bronze Age. They were originally from the eastern steppe, which is in present-day Ukraine and Russia. They are dated between 3200 BCE to 2600 BCE. It is believed that the Yamnaya were the first to domesticate horses and ride horse-driven chariots. Horse-drawn chariots gave them the mobility to traverse vast regions of Europe and Asia. A study of the Y chromosome haplogroups shows that the migration of the Yamnaya to the Iberian Peninsula, Spain and Portugal, resulted in a complete replacement of the existing male lineages with the Yamnaya male lineages. Similarly, the Yamnaya migration resulted in a 90% replacement of the then existing male lineages in the United Kingdom. The Yamnaya also migrated to the Altai Mountains in Central Asia, and then through the Hindu Kush Mountains into eastern Afghanistan and northwestern Pakistan. From the Hindu Kush, they arrived in present-day Pakistan and northwestern India between 1900 BCE and 1500 BCE. They mixed with the people living in the Indus Valley Civilization, spreading their genes to the population. By this time, the mature Harappan phase had declined, and some of the inhabitants of the Indus Valley Civilization had migrated to the Indo-Gangetic Plains and towards South India. Unlike in Western Europe, the arrival of the steppe pastoralists did not result in a replacement of the existing male lineages in the IVC region. Steppe genes are more likely to be found among the Brahmins in India. Due to strong endogamy, marrying within the same class or caste, Brahmins today continue to have higher steppe ancestry when compared to other communities. Some tribes in South India, such as the Paliyars and Kurchas, have no steppe ancestry because they migrated out of the IVC before the arrival of the steppe people. This figure shows the migration of the Yamnaya and its descendants like the Andronova culture into Europe, the Altai Mountains in Mongolia, and from there through the Hindu Kush Mountains into the region of the IVC. The pie chart shows the proportion of Yamnaya ancestry. Notice that ancestral South Indians have no steppe ancestry. The paper by Shinde et al. Shows that the people of the IVC had no steppe ancestry either. This figure is from a preprint of the paper made available under a Creative Commons license. The second paper, titled "An Ancient Harappan Genome Lacks Ancestry from Steppe Pastoralists or Iranian Farmers," was authored by Shinde et al. And published in Cell in October 2019. This paper analyzed the DNA from one skeleton found in Rocky Gari in Haria, India. The skeleton was dated to about 2800 BCE to 2300 BCE, which is in the mature Harappan phase. They combined the genetic data from this sample along with 11 other samples found in Iran and Turkmenistan, dated between 2500 BCE to 2000 BCE. The researchers arrived at these conclusions. The Indus Valley population was a mixture of three ancestral groups: ancient ancestral South Indians, who are related to the very first hunter-gatherers of South Asia; hunter-gatherers from Iran; a small component from Southeast Asia, present-day Thailand, Vietnam, Laos, etc., hunter-gatherers. The genome showed no steppe ancestry, which means the pastoralists from steppe came to the IVC region later. The Narasimhan paper places this migration between 1900 BCE and 1500 BCE. Farming developed independently in the IVC. This figure shows the development of agriculture, animal husbandry, crafts, and cultural practices from the region of the Zagros Mountains to the region of the IVC over a period of about 8,000 years. The people of Mehrgar cultivated wheat and barley, and the people in Uttar Pradesh cultivated rice around the same time, 7,000 BCE, but independent of each other. Several millennia later, the steppe pastoralists brought horse-driven chariots and an early form of Indo-Iranian languages, which gave rise to Avestan and other Iranian languages and Vedic Sanskrit. By this time, the mature Harappan phase had declined. This image was generated using Google's image generation tool. The papers arrived at the following conclusions regarding the spread of Indo-European languages. The migration of the people from the steppe region aided in the spread of Indo-European languages in the Indian subcontinent. The data argues against a trans-Iranian plateau route for Indo-European language spread into South Asia. The custodians of religious text in Sanskrit are the Brahmins, and they have more steppe ancestry than other communities in India. The Indo-European languages are a family of languages spoken in Europe, Iran, and the northern part of South Asia, including Afghanistan, Pakistan, and North India. Indo-European languages include German, French, English, Russian, Italian, Persian, Sanskrit, etc. Linguists believe that Sanskrit, Persian, and Latin have a common origin language called the Proto-Indo-European language. Dravidian languages such as Tamil, Kannada, Telugu, Malayalam, Brahui, Gandhi are linguistically isolated from Indo-European language. The figure on the left shows the Indo-European languages such as Indo-Iranian, Germanic, Greek, Slavic, etc. Indo-Iranian languages can be divided into Iranian and Indo-Aryan languages. Vedic Sanskrit is derived from Indo-Aryan languages. Apart from the Dravidian languages of the south, the majority of Indian languages is a descendant of Sanskrit. The figure on the right shows the location of current Indo-European languages. The R1a Y chromosome haplogroup is dominant in Eastern Europe and moderately high in North India, and these are the places where Indo-European languages are spoken. This attests to a common origin for some of the people in these regions through migration. One must note that languages can also spread via trade and cultural influence. The South Indian languages are not Indo-European, and this region also has low to no steppe ancestry. The figure on the right is courtesy of Wikimedia Commons. This figure shows the gradual increase of steppe ancestry among the populations of the IVC region from 2800 BCE to 1400 BCE. The Rocky Gari sample, which is dated between 2800 to 2300 BCE, has no steppe ancestry. There's no steppe ancestry among the population of the IVC in the mature Harappan phase either. This conclusion is from the Shinde paper. 117 fossils dated 1700 BCE to 1400 BCE from the Swat and Chitral regions of Pakistan show about 49% steppe ancestry. Today, some communities in India, like the Brahmins, have about 20% steppe ancestry. These conclusions are from the Narasimhan paper. We will summarize the archaeological, genetic, and linguistic evidence to decide which of these is correct. As the Indus Valley Civilization declined around 1900 BCE, groups from the steppe region arrived, bringing new genetic influences and cultural elements, such as horse-drawn chariots and languages, which later spread across parts of India. Or, people living in India several millennia ago spread their cultural practices, languages, and genes to people living outside the Indian subcontinent, in places such as Iran and the steppe region, the out-of-India theory. We will first look at the Y haplogroup evidence. In the previous video, we stated that the Y chromosome haplogroup H has deep roots in the Indian subcontinent and is found in about 15% to 30% of the population, especially in Central and South India. If people migrated out of India westwards to Iran and Central Europe, one would expect to see the H haplogroup in those locations. Only the Romani people, who migrated out of India about 1000 CE to 1200 CE, have this haplogroup, and they constitute only 2–3% of the population of Europe. The vast majority of Europeans do not have the H haplogroup or its subclades. We now look at an mtDNA haplogroup. The dominant mtDNA haplogroup in India is M. If people from India migrated to West Asia and Europe, one would expect to see the M or its subclades in the European population. There is no evidence of M or its subclades in Europe except among the Romanis. The dominant mtDNA haplogroups in Europe are H, U, J, and T. None of these are descendant from M. Analysis of the Y haplogroup H and the mtDNA haplogroup M do not support the out-of-India theory. How about the R1a Y haplogroup? Its subclades are dominant among North Indians and is also present among populations in Central Europe. Could this haplogroup have spread from India to other regions? The answer is not straightforward and depends on where R1a originated. If it originated outside India, then a migration would have brought it to the Indian subcontinent. If it originated in India, then the migration would be from India. In a paper titled The Indian Origin of Paternal Haplogroup R1a1, published in 2009 in the Journal of Human Genetics, the authors argue that R1a is much more diverse and found among castes other than Brahmins, pointing to an Indian origin. However, later research has negated this conclusion. The title of the paper by Shinde et al. States that the Rocky Gari fossil, dated 2800 to 2300 BCE, had no steppe ancestry. This suggests that the R1a among the steppe people was not due to a migration of the people of the IVC. The Narasimhan paper states that the first evidence of steppe ancestry is seen in fossils about 1900 BCE, after the mature phase of the Indus Valley Civilization, pointing to a migration into the IVC region from the steppe region. A study of the Y chromosome and mtDNA haplogroups leads to the following conclusions. Small-scale movement and interaction of hunter-gatherers from the Zagros Mountains of Iran to Mehrgar around 7000 BCE. Migration of pastoralists from the steppe region around 1900 BCE to 1500 BCE to the region of the IVC, who brought horse-driven chariots, an Indo-European language that could have been Sanskrit or a proto-version of Sanskrit. A mix of these two, along with people who were already present in India for several millennia, gives Indians their genetic ancestry. Linguistic evidence shows a common origin for Sanskrit and European languages. It is believed that Vedic Sanskrit and later Classical Sanskrit developed in the Indian subcontinent after the decline of the IVC. The Mitanni Empire existed in the northern Euphrates-Tigris region, which is in present-day Iraq, Syria, and Turkey. They signed a peace treaty about 1380 BCE with the Hittites, a neighboring kingdom. The treaty names the Mitra gods, the Varuna gods, Indra, the Nasatya gods, as divine witnesses for the Mitannis. The Nasatya are the Ashvinis of the Rig Veda. Mitanni kings had Indo-Aryan names such as Purusa, man, Indrota, helped by Indra, etc. The genetic evidence suggests this. The people who brought these, now recognized as Sanskrit words, came from the steppe region around 2000 BCE to both these places, the Mitanni Empire and the IVC region. The Mitanni Empire is long gone, but these deities live on in the Rig Veda and, by extension, in Hinduism. There is no archaeological, radiometric dating, or genetic evidence that supports the out-of-India theory. However, they show a migration of people from Iran and later from the steppe region into the Indian subcontinent. The diversity in the features, cultural practices, religions, and habits of the people of India are due to genetic adaptation, environmental influences, experiences, and influences from outside the Indian subcontinent. However, at a fundamental genetic level, there is at most a 0.1% difference between humans. There is much more in common among North and South Indians and between Indians and the rest of the world than there are differences.